Hello, and welcome to our session on simple and compound interest. In this session, we're going to look at the basic definition, how the concept works, and maybe try and come up with the formula for both simple and compound interest, and importantly, see the difference between simple and compound interest and what are the basic principles involved. Okay, so let's get started. So, first of all, let's start with the definition of the word interest. Now, it has many meanings, but the meaning that we are interested for our purposes today is that it is the money paid regularly at a particular rate for the use of money lent. Okay? I'll simplify it further. It is money paid regularly on money lent, right? So, let's say when you're lending someone some money, uh, after some time, not only they are supposed to give you your original money back, they should pay you some extra money also, right? Think of it as a kind of rental or a fee for lending them money, right? Why should you give them money otherwise? So this interest is the money paid on for the use of money lent. Now the other part of it is money paid regularly. That could be yearly or 6 monthly or monthly or daily, depending on what your terms of agreement are, and at a particular rate, right? Now, rate means in terms of percentage or a ratio or what proportion of something. So there's not going to be a fixed amount for example, if you lend someone 1,000 rupees and when you lend someone some 10 lakh rupees, you can't charge them the same amount of money, right? But you can charge them at the same rate. So let's say your rate is 10%. So whether it's 1,000 or 1 lakh, you need 10% extra. Whatever money you give them, you need 10% extra. Okay, so that's the basic idea of interest. It's a rental on money, it's a fee on money, and there is a rate involved. Okay, so let's say to further understand the idea, let's move to an example, a case study of sorts. So this is you, and that is your bank. The character in blue, and that area is your bank. So let's say you have $100 or 100 coins of gold or 100 rupees, whatever your currency might be, and that is the original amount of money that you have, right? Now, it is also called principal when we're talking about simple interest and compound interest. The technical or the official term for the original money is the term principal, right? So now what you do is you go to the bank and you deposit this 100 rupees or $100 with the bank, okay? And then you leave the bank and then you go on a holiday for 1 year, okay? And it is given that the rate that the rental that the bank pays is 10% of your money per year, 10% per year, and 10% of what? 10% of your money, right? So you have left, 1 year goes by. Now this is what the bank will do. It will find 10% of your money. This should be fairly easy. 10% of 100 is 10, right? So 100 was your original money. The bank is calculating 10% of your money. For keeping that money for 1 year, the bank is going to pay you this extra 10. This extra 10 rupees is known as the interest, right? Now 1 year has passed. You will come back and you will go to the bank and you will take your money, right? Now, what has happened is you had 100 rupees in the beginning, but after 1 year, your total amount has become 110, right? And this total amount 110 is made up of the principal amount or the original amount of rupees 100 and the rupees 10 that has been added as interest or as a fee on your money paid to you by the bank, right? Why is it 10? Because the rate was 10%. 10% of your money that was 100 calculated was 10, right? So that is our basic idea. Let's do one more example quickly so that we understand, because the numbers could be confusing. So let's try some different numbers. So again, starting with you and a bank, let's say the rate this time for the bank is 20% of your money, right? And the money that you have this time is $250 or 250 gold coins, whatever you want to assume. Again, you go to the bank and you deposit your money with the bank, right? And then you leave the bank and you will come back after 1 year, right? Now after 1 year, this 250 rupees that the bank kept, now the bank should pay you a fees. How much fee is that? The rate was 20% per year. 1 year has gone by, so 20% of your money. Remember, a very fundamental concept in percentage is the concept of base. Where is the percentage operator working? So 20% of your money, which is 250, will give you 50 rupees extra or $50 extra, right? Again, after 1 year, you will come back and you will take this money with you. This will be your final amount. This 250 plus 50 will be your final amount, and this is known as amount in simple interest and compound interest problems, right? Yeah. So this is how the basic process of interest works, especially for a 1 year period. If I'm looking at only a 1 year period or one time cycle, there is not, you cannot differentiate between simple interest and compound interest. That difference only comes when there are more than one time cycles involved. We'll come to that idea in a minute, right? But I hope you got the idea of how the process works. Now, observing the same process, I can see that my, if I want to come up with a formula, that my final amount, which is known as amount, is equal to the principal plus the interest, right? In this case, the principal being 250, but we want to come up with a formula. So generally the term principal and the interest, right? And how is the interest calculated? The interest was in the previous example 20% of your money or 20% of the principal. That means this percentage operator, this rate, this 20% is working on the base of principal. In this case 250, but otherwise the concept of the original money. The rate of interest works on the original money, right? And how would I calculate it? It would be 20 by 100 of the principal or 20 by 100 of 250. In this case, the value being 50. Yeah, this is easy enough so far, right? Staying with the same idea, we want to come up with the basic formula. So amount is equal to principal plus interest. So amount is equal to principal, and the interest is itself is equal to, let's say in the previous case, 10 by 100 of p when the rate was 10%, right? I want to generalize the formula, so instead of 10 or 20, can I call it R, the R being the rate of interest in any given story? So my basic formula should start looking like this. Amount is equal to principal plus R percent of principal, or principal plus R by 100 into principal, right? Now, the next thing is quite mathematical, and I mean, you may or may not do it, but it's your, I mean, choice basically. I would understand it in all possible ways. The P or the principal can be taken out and common of the whole thing. P out of the first part of P and the R by 100 P. The P can be taken out. It's a very basic mathematical step. I'm not going to cover it. So the P gets taken out as common, and what is left inside is P into 1 plus R by 100. So now if you have already seen the simple interest kind of a formula, this is how it begins to look like it. In the standard formula, there is a term of n or time, number of time periods involved. We'll come to that in a second, right? So this is how my formula should begin to look now. Another way of looking at it is by looking at the same numbers, let's say of 10%, and our formula being amount is equal to P into 1 plus 10 by 100. Now, if I solve this 1 plus 10 by 100, it becomes 110 by 100 or 11 by 10, right? Which, if I interpret it in language, also means that principal is essentially increased by 10% after 1 year to get to the value of amount, right? Or there's a multiplying factor of 11 by 10 for P, which takes you to the amount, and a multiplying factor of 11 by 10 means an increase of 10%. Or amount is 10% more than the principal, right? So that's why, I mean, a very clear understanding of percentages can go a long way in terms of building further speed in these kind of questions. So please go through the percentage and application videos. Your life would become very, very easy when dealing with such problems, or with problems across the subject of arithmetic like weighted averages, time, speed, distance, etc. So do go through the percentages an applications video, so that using of multiplying factors and understanding this more than or increase of 10% or a decrease of 10% should become fairly easy. Click on the link to go to those videos. Okay, with that, let's move on into a case of simple interest for 3 years. Okay, A couple of points here. First of all, simple interest might seem easy and mathematically easier and an easier formula, but in the real world, it's rarely there. For example, if you go to a bank and deposit some money for a couple of years or maybe 5 years, the way the interest will be generated is compounded, right? So, simple interest is actually not there in the real world or not there too much. And more often than not, let's say the interest on your credit card payment or the interest you have to pay the government if you're late on something, or the interest that you're getting on your savings in your bank account, all of them work in a compounded manner. So simple interest is a off case, but this is how it goes. Okay, so let's say going back to our same story, you have 100 rupees and this time you're depositing it in the bank for 3 years. Okay, so you go to the bank and you deposit the money and then you leave, right? So we'll see what happens step by step after each year. Okay, so after the first year, the rate is 10% and the principal is 100. So 10% of 100 will be calculated and the interest generated will be rupees 10, right? So that is exactly like what we did earlier. So what's new? Now 100 rupees was the principal. Now what happens in the case of simple interest is across the time period or over the time period, the principal remains the same. Now, this is the fundamental difference between simple interest and compound interest. That in compound interest, the principal keeps changing. The interest is added to the principal and a new principal is generated. But in the case of simple interest, nothing like this happens. It is, as the word says, very, very simple. So the rate again works on the same 100 rupees, and for the second year or after the second year, another 10 rupees would be generated. How? 10% of 100 again is 10, right? Now, after 3 years, what will happen? Again, the idea being that in simple interest, the principal remains the same. The original money keeps acting as the principal. The rate of 10% would work on this 100 rupees again or $100 again, and again generate 10 as the interest for the third year. Now, you will come back after 3 years and take away all your money. So, what will you get? You will get your principal back, that is 100 rupees, and you will get 30 rupees extra, right? 10 for each year, right? So my amount is my principal plus the interest for the first year plus the interest for the second year plus the interest for the third year, right? Now, because the rate was constant across these 3 years, and which is more often than not the case, you get the same rate of interest for a few years, you also see that the amount of interest generated is also the same. So, this is also an insight or a shortcut that you can use. So, for example, if you know that in 5 years, total simple interest generated is 100, you know each year 20 was generated, given that the rate was same, right? Or anyway, just an observation for now. When we do more, when we start solving problems, we'll come to these observations and using them in problem solving. For now, just notice that the interest amount is the same for each year, and that is also because the rate is same for each year, right? And the principal also acting the same, principal being the original, right? So this is how fundamentally simple interest works for a multi-year period. Now we're talking about years here. It could very well be days, right? It could be a 10% interest per day, though rarely would it work like that in the real world. But let's say hypothetically, it could be 10% per day. So in our story, it would be after 3 days, right? So, so this is the case of simple interest with multiple time cycles involved, multiple time periods involved. Okay. So let's try and look at the formula again. I can see from the diagram that the amount is equal to principal plus the interest for the 3 years, right? Yeah. Now principal plus interest for year 1 plus interest for year 2 and the interest for year 3. Principal we know is 100, and how do we calculate the interest? We say okay, 10 by 100 of principal for the first year, 10 by 100 of the principal for the second year, and 10 by 100 of the principal for the third year. We want to come to a general formula from this specific example. So instead of 10, can I say R% or R by 100 of the principal for the first year, R by 100 of the principal for the second year, and R by 100 of the principal for the third year. If you observe it here and say in a question the rates were different for every year, so I could have changed this formula to R1 plus R2 and R3. R1 being the rate in the first year, R2 being the rate in the second year, and R3 being the rate in the third year, right? So I hope you get the idea. And again, we're looking at the same idea that amount is equal to principal plus interest, and interest is R% of the principal. Now, the only difference is being that in simple interest the principal remains the same for multiple time periods, right? The interest does not get added to the principal to generate a new principal, which is the case in compound interest, right? Let's look at this formula in a little more detail. So I know my amount is equal to P, which is the principal, plus R by 100 of P, plus R by 100 of P, plus R by 100 of P. So this R by 100 of P is repeating 3 times. So can I simplify this into amount being P plus 3 into R by 100 of P, right? Because the term R by 100 of P is appearing 3 times. Think of it as A. So it is A plus A plus A, which becomes 3A, right? Uh, Now, just the way we replace 10 by R, we want to come to a general formula. So instead of 3, which is the number of time periods, can I call it N for number of time periods? In some formulas, in some books, this is also called T. So don't get confused, it's just a name for something, right? So number of time periods into R by 100 into P is your interest. Added to the principal, you get the amount. If somebody was asking for just the simple interest formula, my formula would be N into R into P by 100. To understand it logically, I would still see it as N into R by 100, which is R% of P. R% of P is the interest. It is multiplied by N for having multiple time periods, right? Now again, just a last mathematical step is to take the P out as common. So it becomes amount is equal to P into 1, which is the replacement for the original P, plus N into R by 100. So the P from the equation number 2 has been taken out common. Very common, basic, easy math step, hopefully for most of you. So P has been taken out and 1 plus N into R by 100 remains. So now I think this is the formula that you will find in most books or most textbooks or formula listing, right? So that's the idea in simple interest. Okay, so let's look at another way of interpreting this formula or another way of using this formula. So we know that amount is equal to P or principal into 1 plus R into N by 100, right? We just saw the formula. But instead of R and N, let's put 3 and 10. 10 being the rate of interest, 10%, and 3 being the number of time cycles or 3 years, right? So this the entity inside the bracket can be solved to or can be rewritten as 1 plus 3 into 10 by 100 would become 130 by 100 if you solve it for yourself. 1 can be written as 100 by 100. 100 by 100 plus 30 by 100 becomes 130 by 100, right? Or 13 by 10. Which means that principal is increased by overall 30% after 3 years. That is 10% for each year. In the case of simple interest, for 3 years is the same as saying 30% overall of the principal, right? So I hope you get the idea. Or another way of saying is amount is 30% more than the principal, right? Again, let me repeat the idea that having a control over your percentage process or knowing percentages and ratios well will add extra speed to your simple interest, compound interest kind of problems. In fact, a thorough understanding of ratios and percentages will help across the board in the arithmetic section of the exam or generally in interpreting percentages or ratios, applied problems anywhere in life. Moving on, so let's move to compound interest now. Let's look at one example of compound interest and try and come up with the formula and an understanding of what is happening in the case of compound interest. So let's again start with you and a bank. So you go to the bank and you deposit your money and you leave your money with the bank, right? And let's say you're gone for 3 years and this is a case of 3 years. The rate is still 10%, but this time it is 10% compounded annually. Now, what does that mean? Now, the first year will exactly work like the simple interest case, or the first year, there is actually not too much of a difference between the two anyway, right? So, after the first year, the 10% rate operator will work on the principal and generate an interest of 10, right? So, this rupees 10 is the interest for the first year. Now, this is where compound interest starts differing from the simple interest. Because what happens in compound interest is this 10 gets added to the principal and you get a new principal which is 100 plus 10 or 110, right? This is the fundamental idea, the changing of principles, right? In compound interest, the principal keeps changing. In fact, this is how your bank would work. So if you go to a bank and leave money there, or if you go to the bank and just ask them that the rate of interest is simple or compounded, they will tell you that it is compounded. That means your principal and the interest that it has generated together becomes the new principal after the given time period, right? So this 110 is the new principal. What does that mean? That basically for that 10% rate operator, the base now has changed. We know that in percentage, a percentage is always working on a particular number or an entity, and that is thought of as a base, or it is thought of as 100. Again, please go through percentages for a better understanding of bases and shifting bases, etc. So anyway, the new principal is 110, 10% of 110. So after the second year, the interest generated would be 11 rupees. You can calculate 10% of 110 for yourself. 10 by 100 into 110 will give you 11, right? So for the first year, the interest generated was 10, and for the second year, the interest generated is 11, right? So I hope you see the difference. In the case of simple interest, even after the second year, the interest was still 10 because the principal was still the same, or the base was still the same as the previous year. Here, the principal got updated, the interest got added to it, and a new interest was calculated on the new principal. So you got 11 as the interest for the second year, right? Now, I hope you get the idea. This 11 will be further added to the principal to get a still newer principal, right? And that will be 100 plus 10 plus 11, or 121. So after the third year, I will calculate 10% of this 121 and I'll get 12.1, right? 10% of 121 is 12.1. So I can see my interest for the first year was 10. My interest for the second year was rupees 11, or $11, and for my third year was 12.1, and how the principal keeps changing. Now after 3 years, again you will come back and you will go to the bank and you will take your money. So your final amount is equal to principal. Conceptually still the same. It is interest for the year 1 plus interest for the year 2 plus interest for the year 3, right? But what's difference is that the interest is each time for each year is calculated on a new principle. Get that idea going in your head. Okay. Another way of looking at it is that after first year, or when we started off with the principle, and after the first year, it got multiplied by 110 upon 100, or it got increased by 10%, which is the same as saying it got multiplied by 110 by 100. Yeah. If this idea is troubling you that how did we come to this so quickly, again, going through the percentages module will be a very, very good idea. So after 1 year, this is what is our amount is, right? If I had only gone for 1 year, this would be a final amount, right? The idea being the same, this amount becomes the new principal, or P dash. Let's call it P dash symbolically. Okay. So for the second year, this new principal again gets multiplied by 110 upon 100, right? Or 11 by 10. So this is my amount after the second year, P into 110 by 100 into 110 by 100, or P dash into 110 by 100, right? This becomes P double dash, or my new principal still. And again, for the third year, this now will be multiplied by 110 upon 100. And finally, this is my amount after 3 years. If I remove all the symbols and the brackets, this is what I'm left with. P into 110 upon 100 into 110 upon 100 and into 110 upon 100, right? So get the idea that my final result will be 110 upon 100 cube into principal. Let's split that 110 upon 100 back into the way we started off a couple of minutes back in the formula. and that will become 1 plus 10 upon 100, right? So each of them can be further expanded into 1 plus 10 upon 100. So I can see that my formula for amount would be P into 1 plus 10 upon 100 raised to 3. Instead of 10, can I call it R now because we want to come to a formula? Yeah. And instead of 3, can I call it N? So there I get my compound interest formula. My amount is equal to principal into a whole bracket of 1 plus R by 100 raised to N. So I hope you understand how the formula works and what do all of these terms mean, and what is the principal difference between a simple interest and a compound interest. Okay, that's about it for this session. We don't want to make it too long. In the next session, hopefully, we'll look at a few problems and try and solve a few problems and use our formulas and or our insight to solve them quickly. Okay. If you have any specific percentage SI, CI problems, drop them in the comment section. I'll try and use them for the next session. Okay. So that's it. See you soon. I'm leaving you with the animation for both SI and CI. Remember the basic difference being the base is the same, the base is not the same. Keep repeating it like a mantra. The base is the same, the base is not the same. See you soon.